We are going to listen to the third presentation of today, and it's a duo, so two persons are going to present. It's actually Adam, Sandor, and Anders Eknert, and they are working for Styra, if I pronounce it well. And they are going to talk about zero trust authorization with Open Policy Agent. Give them a big hand, Adam and Anders.
All right, welcome everybody. Well, this talk is going to be a little bit different from the previous ones. It's going to be pretty technical, and we're not going to be talking so much about identity, but much more about authorization and how to use that identity in the applications. My name is Adam Sandor. I'm a solutions architect at Styra for 1.5 years. Before that, I used to work as a consultant in the cloud-native space with Kubernetes and these technologies, and before that, I was a software developer. And here's my colleague Anders. He's going to introduce himself and give you the big picture view, and then I will actually be showing you all a small demo how our technology works in practice. So, Anders.
All right, thanks, Adam. I'm Anders. I work as a developer advocate at Styra, which is the founders of the Open Policy Agent project. Before that, I have a pretty long background in software development, where I used to work in identity. So I worked for a few identity vendors, and I worked in teams where we kind of integrated identity into our organizations. One thing we didn't really do there, like we kind of always shied away from like the topic of authorization. So at an identity vendor, our responsibilities ended as soon as we handed out this token or something where you proved your identity. Very well. So when our users would ask us, like, okay, so now what do we do with this? Like, we know who the user is. Like, how do we use this? And that was your problem. It's not my problem. Like, I'm in this identity vendor. But a few years later, I guess that was karma for me. So I found myself in a team where it now was my problem. So that's kind of how I got involved with Open Policy Agent, because we were starting to look for something like, since I had experience in identity, we started looking for something similar for authorization. What we wanted is basically like a few standards to rely on, somebody to show us the way. And it turned out there wasn't really anything like that for authorization. All these things like OAuth, OpenID Connect, they are very coarse-grained in terms of authorization. They do provide a whole lot more for authentication. There's a few legacy or older standards like SACML and so on, but it just wasn't something we were willing to work with. So Open Policy Agent, it's an open source policy engine or an open source project, a general purpose policy engine. I think you can transition there. Yeah. So it's an open source policy engine. We have like 130 million downloads, 300 contributors, 6,000 users on our Slack, and so on. So it's a vibrant open source project. The problem we were trying to solve then with the OPA project, it's basically this. We have like this wide heterogeneous tech stack, and at the team I was in at the time, we were in an organization. We had development teams in 13 different countries. We had around 700 microservices, and we had about 8 or 9 different programming languages. And when you do identity, you kind of delegate that responsibility to some centralized component. So you might buy into an identity server or an open source solution or whatever, but it's a centralized solution. The difference with authentication and authorization is, of course, like you authenticate maybe once a day, or maybe even less than that. Well, authorization needs to happen all the time. So that using that same solution where you delegate that responsibility to a central authority or a server, it doesn't really scale when you have 700 microservices. And for each request, they need to go and ask somebody else. So it wasn't a scalable model. And that was a real challenge for us. And additionally, we wanted a way to express like our rules, not just for what a user is allowed to do, but also for all of these other technologies. We wanted a way to describe rules for what type of infrastructure we wanted to deploy in our cluster, what type of security configurations we were to allow. So policy for our build and deployment pipelines, for our infrastructure, and for our applications. And that's basically what OPA provides. It provides a way to describe policy, and of course that includes authorization policy, in a generic or general purpose fashion. So how does it work then? There's a few components involved, but it's a rather simple model. And the way it works is you have a service, and a service, we have a pretty broad definition of a service here. It could be a microservice, a REST API, it could be a Kafka broker, basically anything that services a request from a user or some other service. And rather than making a decision of its own, should we allow this or not, that service sends a policy query over to OPA. So it kind of delegates that responsibility to OPA, similar to how you do it for identity. But in this case, you can move OPA as close to your service as possible. You have your service query for a decision, and then based on the policy that OPA has been provided with, and optionally like data around that could be useful for that policy decision, OPA makes a decision, and it sends it back to the service. So the service is basically unaware of the concept of authorization or permissions or so on. So you can, in the same way that you delegate the responsibility of storage to a database, you delegate the responsibility of policy decisions to OPA. Yeah, and I think we can move on to the next slide. So if that is the kind of zoomed in version, then a more like a bird's eye view could be something like this. So of course you have a user, and by user you kind of have a pretty broad definition there too. That could be a device, it could be a drone or a cell phone. But anything, the first step is obviously to authenticate or identify the user, and then once that is done, the result of that authentication is commonly something like a token. Maybe it's a JSON web token containing some data that we'll need in order to authorize the user. So one thing you might see here and notice is like, why is there an OPA, or why is there like a little helmet in each of these services? Can't you just do that in the first service? Surely that would be a much simpler model. And that's basically how we did authorization for the last 20 years or so. That's the gateway model, where you say, you have a gateway in front, I'll authorize the user here. Once you're past the gateway, it's an open highway. You can do whatever you want. And the problem with that model is, of course, that once you're past the gateway, you can do whatever you want. And if you somehow make it past that gateway without being authorized, then there's very little you can't do. So in recent years, the zero trust security model, it basically says that we make no assumptions whatsoever. We don't assume that anything about user identity. We don't assume anything about permissions. The service in the back here should not assume that this request has passed any other number of services, but it should be an independent unit as far as authentication and authorization is concerned. So in each of these services, we do authorization, or we check the identity of the user and determine whether the request should be allowed or not. And we do that based on policy we have provided. In this case, we have a control plane. It's a fancy word for saying something like an S3 bucket. There are also more advanced control planes like the Styra DAS. So the control plane distributes policies asynchronously, so there's no, like, at the time of the policy decision, there's no communication to some external server. So even if the control plane is down for a few minutes or so, there's no downtime in the system as a whole. Additionally, each of these OPAs report their decisions back to the control plane, so you can follow that up in audits and so on. See if there's if you have a lot of failed requests or unauthorized users or so, that might be something you want to look into. So I think that's kind of the high-level view of what OPA is. And I think Adam's going to take it away with a more hands-on demo.
Yeah, thanks, Anders. So yeah, let's jump into the demo so you can all understand better how this actually works in practice and how do these policies really look like. So we will be showing the kind of fake customer support portal of a consumer bank where each customer support agent logs in and can do different things based on their role, their role level, and which geographic region they're in. So each of these users will have certain attribute and will be basically implementing a sort of attribute-based access control using the Open Policy Agent and its and policies. So these are our 3 agents. Agent Smith is going to be a level 3 agent in the EU, Agent Brown level 2 in the EU, and Agent Jones will be level 2 in the US. So keep that in mind when we will be talking about what rights do they have. All right, so we jump into our demo application first as Agent Smith to explore a little bit what more, what Agent Smith is able to do in this application. So Agent Smith is a level 3 agent in the EU. That means he can open the details of an EU bank account. This always happens for some weird reason, like once, and then it goes away. Cool. So we can see the details of the user, and he can see what transactions did this user make on their, or this customer make on their bank account. Now, Agent Smith can see all the transactions, both the successful and the failed ones. We'll see that other agents with a lower level cannot do that, and Agent Smith can also block an account. Now all this is very standard application functionality, nothing fancy here, nothing you could not do without the Open Policy Agent. What the Open Policy Agent brings into this picture is that you do it with a very different, more modern architecture where all your policy is managed from that single control plane. And this is our SaaS product, the Styra DAS, that acts as the control plane for the open source Open Policy Agents that are running inside the application. So here we can see all the decisions that have been taken by OPA. For example, here we have a decision where we authorized access to this EU accounts details that we have just seen. And basically here we get all the data about like the user and the account. I'm not sure how much readable that is on the screen. I think it's not too bad, but it's so we have all the data, and then we have a policy decision result that says allowed true. Basically, this is what the Open Policy Agent did. And in Styra DAS, you can replay this decision against your policies. And we can see here, this is our policy here. I'll make it a little bit bigger. So basically here in our policy, we are defining things like if the user doesn't have the customer support role, then we are just giving them an error message. If the user doesn't have at least role level 2, then we are also denying their request. And finally, if the user is from a different geographical region, which Agent Smith is not in the US, so if he tries to access a US account, he gets this error message. And you can see this error message is actually coming from our security policy that is centrally stored in Styra DAS. So this is the first step to understand that all the policy is inside Styra DAS and is distributed out to the agents in the field, basically, who are doing the actual authorization for the application. Now, next thing, we can log in as Agent Brown, who is a level 2 agent. And Agent Brown will have the same restriction on the US account. He can open the EU account, but he will actually, because he's only level 2, he can only see failed transactions, so he can troubleshoot with customers, but he cannot see like all the transactions of what's happening on an account. So, and this is happening, again, based on the same mechanism that the application asks the Open Policy agent for a policy decision. And we'll see that that should be popping up here in a moment. And every time the Open Policy agent makes a decision, it also uploads the decision log. So we're getting an automatic audit trail of all the security decisions that have been made in the application. Yeah, or maybe this is the decision. Let me just check. Yeah, so here the Open Policy agent is also returning a list of filters that the application should apply on the database query. So this is a thing where the application needs to be integrated with the Open Policy agent so that they can communicate. The Open Policy agent makes a decision, and the application will apply that policy decision. So here we have this policy that says for any user that is less than role level 3, we will filter for only the failed transactions. And now if I want to give Agent Brown an exception from under this rule, I can just say input.subject.userid doesn't equal Agent Brown. And in that case, this rule will not apply to Agent Brown. I'll publish my policy change, and this will now propagate to the Open Policy agent running inside the application. It might take a little moment until that actually happens. It still did not. Input subject user ID doesn't equal Agent Brown. That should be good. Ah, there we go. So suddenly Agent Brown sees all the transactions. So this fast, we could make a policy decision, a change in the policies, and this got applied to the application. Of course, now I don't have in this short time to go into like better controls that we could put. We maybe don't want to be so quickly applying new policy to our production systems, but it is possible and it happens very dynamically. And one last comment here, that this is basically, it is programming to change these policies. This is a policy language that is developed for the Open Policy agent. So it is a more technical task to modify these policies. But that also means these policies can be very powerful. So it's not a UI where you can click 3 checkboxes and that's all you can do. But you can express any kind of company security policies in this language. Yeah. And finally, I'll just quickly show an architecture diagram for those who are interested in like how does this look like. Basically, we were editing the policies in the Styra DAS UI here, and we had a microservice application running with multiple microservices, each of them having an Open Policy agent attached to them. So each of them communicating with a local Open Policy agent. So these authorization decisions happening very, very fast, because that's very important that basically there will be thousands of these decisions made every second in a large application, and they can be done very quickly, but the policy is still managed centrally. So you can change it in one place and it will be applied to all these agents running in the system. And this is just one use case where Open Policy agent can be used. This is the application use case. And as Anders was showing, there are many others like infrastructure authorization. So you can bring all these different use cases into one central control plane. Yeah, and that's it. Thank you very much for listening. There are some resources there. You can find us also on Twitter. And you can also ask questions, or maybe, I have no idea how much time we have left.
I think we will have time for one question at least. Okay, I come to you because you need to speak through the microphone for also the audience at home.
Thank you for the presentation and the demo. Always brave to have a live demo. My question is around auditing, like how typically, companies typically have audits around user access regarding applications and so forth. If you use a policy-based technique, then it's hard to match a role to an access because there is a policy in the middle.
Yep.
How do you cope with that, and what are your
that's a great question. Well, in the end, there is always policy. Even if you would have a simple RBAC model, there is the policy is that the user has to be in some role. That's basically, your policy becomes very, very simple, but there, in practice, there is some policy. And of course, in this case, you can make that policy more complex and or even not use any roles or whatever that could be like reviewed. Okay, is this user in the right role? However, what you can do is, you can, if you're interested in, let's say you have certain resources or certain actions and you have users and you want to know who can do which of these actions, you can actually just start up an open policy agent and just ask it for all the combinations of actions and users, is this allowed according to the policy? And that would give you a report on exactly who has access to what. The other option is, of course, reading the policy, which is depending on the type of policy, it can be hard or can be easy. Like the policies we've shown today, they are pretty easy to read, so you can kind of see like, especially, and it sounds more complex, but if we look at these policies, they are simple because they aggregate access. So you don't have, if you know that all your level 3 users can do certain thing, you don't need to assign 5,000 users to roles and review them whether they are in the right role, right? You can, because you just know that if they have that attribute, this policy is going to grant them access. So it's a bit of a different world, requires a bit of a different mindset, but it is a more flexible and more powerful system. Does that answer the question?
Thank you very much.
Thank you, everybody.